Okay, there it goes. This computer's really bogged down. What a piece of junk. My gosh. Guess I'm going to have to set my alarm a few minutes early if I want to have the computer ready to go for class. All right, so you've just turned in homework 1. You uploaded that to Blackboard. I got a couple of emails over the past few days, and that's great. Another way to get in touch with me is Microsoft Teams. And if you're not a Microsoft Teams power user yet, it's pretty easy. There's like a bar across the top of the program where you could type in like a word if you were searching a thread for a certain keyword. But you can also type in names across the top. And when you type in the name and then click on the name, it'll take you to a window that includes chat box, but also at the top you could place an audio call or a video call. Don't use the chat box because I don't notice those chats when they come in, but if you place an audio call or a video call, then that'll definitely get through to me. So the advantage of that compared to an email is that you can share your screen with me and show me what you're working on if it's a spreadsheet, or I can ask a follow-up question if I don't exactly understand what your question is. And so email's okay, but it's, that's like last decade. Today's decade, as far as getting help virtually and electronically and remotely, I think Microsoft Teams is the more powerful option. So, or you can stop by, and I've had a few people do that, and that's great. I'd love to see you in my office. Our next assignment is homework 2. You can find that on Blackboard. All of the assignments for the whole semester are on Blackboard right now. And I know some people are getting an early start on that, which is great. You kind of have to balance, though. You can't get too far ahead. Otherwise, you're figuring out things on your own that we haven't talked about in class yet. But then, if you look at the homework before you hear the lecture, then it gives you a little more insight onto what you may want to know and some of the key aspects of that. All right, so today we're going to be talking about section 1.8 from our book, Compounding of Interest. And before we get into it, are there any questions? Thanks again, by the way, for wearing your mask. It just warms my heart that I don't have to be the bad guy telling people to pull the mask up over the nose, because that's really not the role that I want to play this semester. All right, so we're going to talk and compare two different interest calculation schemes, and simple interest is almost such a rarity that it's just an academic principle rather than something you'll encounter in the real world. I mean, I guess maybe unless you get a loan from your parents and they're just trying to be nice to you, but no bank is ever going to charge you simple interest, and I think you'll see why with the illustrations we have. A simple interest loan is where the interest amount is just based on the principal, and there's no compounding of interest, which is where they charge interest on top of the interest. So in a simple interest loan, the way that you would calculate the interest amount is it's the principal, which is the original amount that you received from the lender, multiplied by the number of periods. And notice, by the way, this doesn't say the number of years, because your loan periods could be some period other than a year. It could be a duration of every month that you're paying some portion of the interest to the lender. It could be quarterly. And a lot of companies, when they take out loans from people called bonds, a lot of companies will pay their interest on a quarterly basis. And so periods and years, that's not necessarily the same thing. Oftentimes our periods are 1 year in duration, but not always. So number of periods multiplied by the interest rate per period. So that's how you'd find the interest amount. Remember, capital I is an amount of dollars, where lowercase I is a rate, meaning an amount per time. So on the basis of interest per period. Now, just as an illustration with some specific numbers here, if you take a loan of $100,000 for 3 years, then the repayment amount, if this is a simple interest loan, would simply be N for 3 periods, where it's yearly periods. I is 0.1 because it's 10% per year. And so the interest that you'd pay would be $30,000. And the total amount due would be the principal amount of $100,000 plus the interest that had accumulated, where they're not charging you any different amount of interest in the 3rd year than they did in the 1st year. It's just every year there's a fixed portion of interest that is applicable. So that's simple interest, but far more interesting, both from a quantitative perspective and also because it's more real world, is compound interest. Now, what makes this different from a simple interest loan is that the amount that you owe the lender continues to pile up over the course of the loan, and each year you have to pay an interest amount on that year's balance. Not the original amount that you borrowed, but just how much is due this year is what dictates the interest amount for this year period, is all the previous interest amounts get factored in. And so we'll take a look at the formula and an illustration for that. But the basic idea is that the interest amount is the principal, which is the original amount you took from the lender, all of the accrued interest from previous years, and then that's combined together and multiplied by the applicable interest rate per period. So here's the formula. And you know, when I was in school, a formula like this, sometimes it'd make me feel a little bit anxious. It would seem pretty complicated. But actually, this formula is relatively simple. So let's just talk through it together. What this is saying is you can determine the interest amount for a given year. So this is capital I, meaning interest amount. T just means in some year T, you know, a certain time, a 1-year window. So the interest amount that you owe during this period would be based on the principal amount that was borrowed and then the sum of all of the previous interest amounts. So in each previous year, a certain amount of interest had accumulated, and you combine them together for all of the previous years with the principal, and then the amount of interest due that's this year is that quantity multiplied by the interest rate per period. So let's look at a step-by-step illustration of how we'd apply this summation approach. All right, so that same $100,000 we talked about in the simple interest illustration, $100,000, interest rate was 10%, and it was a 3-year period. But this time, we're going to make it compounding rather than simple interest. And so if it compounds over time, what we're going to see is that the ultimate amount due is more than if it had been a simple interest loan. Okay, so in the first year, what happens is you have to pay $10,000 of interest because what you took at time 0 was $100,000, and during every annual increment you're paying 10% as the premium or the reward to the lender for the privilege of taking their money. So you have now owed $10,000 in interest plus the principal amount of $100. So at the end of the first year, you owe the lender $110. And so the idea here is you're not paying any amount until the very end. You're going to do like a lump sum repayment rather than on an annual basis. So this interest just continues to pile up in the eyes of the lender because you as the borrower haven't yet repaid anything during the first year. And so now during the second year, the interest amount that's due is 10% of the previous balance. And our previous balance is $110,000. And so 0.1 times 110,000 is where the 11,000 comes from. So at the end of the second year, now we owe the previous balance of 110 plus the new interest that accumulated during the second period. So the total is 121,000. And then I think you can probably see what the pattern is going to be. In the third year, 10% of the previous year's balance. So the interest during the third year is $12,100. We combine that with the previous year's balance of $121,000. And so for a compound interest loan, instead of it just being $130,000, because you're having to pay interest on the interest, the total amount due at the end of the third year is $133,100. So that's why banks like to charge compound interest, is they end up getting more. They get more because they see it as they haven't gotten any money back, and so you owed them at the end of the first year 110, not 100. 100 is how much you owed them at time 0. So from the perspective of the lender, the amount you owe is taken into account on a regular basis rather than just at the beginning of the loan. Okay, hopefully that makes sense. Are there any questions about this idea or the step-by-step that we've just gone through? I like questions, so if you've got any, don't be shy. So this formula, remember, what it says is you can find the interest amount in any year by adding together the principal and all the previous interest amounts. And so let's just say for the third year, how much interest was due in the third year? It's 100,000, which is the principal, and then the interest amount from the first year and the second year. So combining that all together, and then multiply the sum of those things by 0.1, and so the interest amount of 12,100, we don't necessarily have to break this calculation out with so many rows. We could apply the formula on a more individual basis for a given year. Now, when we start using spreadsheets a lot, we're going to use Microsoft Excel for about half of the class meetings during our semester. And I'll tell you, I'll give you a warning, but there will be a certain point where you need to bring a computer to class each day. But when we start using Excel, calculations like this will be really easy, because what we'll do is we'll just set up the formula one time, and then we'll drag the cell down row by row, and then the computer will just do the calculations for us. And so we'll sort of be designing the solution and letting Excel do the calculations for us. And this is an illustration of something that could easily be automated using Excel. And if you're not already really comfortable and familiar with Excel, by the end of the semester you are going to be very comfortable and proficient with Excel. That's one of the side benefits of the way this class is taught, is just it really increases your capacity to use that tool. Okay, we looked at this problem at the end of class on Monday. This was the fourth in our in-class exercise questions. And what we did was we were going to find out what is the amount that you would have to pay at the end of the fourth year if you received each year $12,500. And so what I did was I labeled each one of these arrows. Do you remember how I called this like A, B, C, D? And I went through the step-by-step process of determining if you have this $12,500 at year one, how much is it equivalent to if you move it forward in time through compounding to year 4. And so what I did was I used this formula, and when I moved arrow A from year 1 to year 4, then the n in the equation was 1, 2, 3. And then this arrow B only had to move forward 2 years in time. And so the approach there was just to treat each one of these arrows as an individual amount that was unaffected by the others. Even though we know it's an annual series, we're kind of treating each arrow as a present value that was being compounded into the future. So that was one of the approaches. The other was to use the find f given a formula. And do you remember we talked about that standard approach that we use for summarizing and describing what kinds of problems these are? And so this is find f given a type problem, and the formula for find f given a is in your book. I'll post an equation sheet online that also has all of these formulas for find p given f, find a given f, and so on and so forth. But this is the formula. We solved the amount both ways, but we could also just take the compounding approach like we saw from the previous slide, where using Excel we could set it up row by row. And so for the first year you could see that you received $12,500, and we previously didn't have any loan balance because there was nothing that happened before year 1. And if this is a 5% loan, like it says in the problem statement, then the 5% loan is being applied to $12,500 because that's how much we just took at year 1. So at the end of the period, meaning here at the end of the period between 1 and 2, we owe 5% of the $12,500. And so the balance for this 12,500, if you just move it 1 year forward in time, it's 13,125. And then we can start to throw in the second year. So what I'm saying is, if you move the 12,500 from year 1 to year 2, it becomes 13,125, and then you can combine it with the amount that you're taking out at year 2, 12,500, and find the combined amount, and 5% interest is applicable to that, and you can calculate a cumulative amount owed. And so step by step, row by row, we could use Excel to find that same quantity of 53,877. And in case you've forgotten, that was the answer to the in-class exercise, problem 4, whether we solved it this approach or this approach. And so what I'm just illustrating, I'm giving you a preview of we're going to start using spreadsheets as a tool that will allow us to do similar things, where we'll calculate how much interest is applicable for each year, and then by dragging the formulas downward through time, calculate the cumulative total.
So
yeah.
Would like those two formulas right there, would that like account for compound interest or like simple interest?
This one accounts for compound interest directly. This one, the way that we were applying it, accounts for the compound interest. So yeah, they're not. These aren't simple interest formulas. Okay, another aspect of whether interest is simple or compound is that interest rates can be expressed a couple of different ways, nominal versus effective. And what you should keep in the back of your mind to help distinguish between nominal and effective is nominal is kind of like not really. That's how you should remember what it means, is that's not really the interest rate. And let me explain. Nominal interest is where the interest is being compounded more than once per year, but it's being quoted on an annual basis without accounting for the effect of compounding. So just for example, if your credit card said that it's a 16% interest rate per year, but then your credit card is compounded quarterly, then what applies there is 4% interest per period. And so the interest rate per period, is 0.04. And nominally that's 16% per year, but that's not really 16% per year, because if it's compounding more frequently than annually, then there's going to be interest on top of interest. And so there's a way for us to apply a formula and account for that interest effect, and that is the idea behind calculating the effective interest rate. So 4% per period, if it's compounding 4 times in a year, the effective annual interest rate is going to be greater than 16%. And the way that you can calculate how much the effective annual interest rate is with this formula. And so this is the formula for the effective interest rate. So I effective is going to be the nominal rate per year, R. And so remember, in this example that we were just talking about, the annual interest rate per year was 16%. So I was saying R is 0.16. And M, the number of compounding periods per year, is 4. And so let's calculate the effective annual interest rate. It's not really going to be 16%. That's not a very good one. M is 4. Okay, so the effective annual interest rate is 1 plus 0.16 divided by 4 to the power of 4 minus 1. And I would guess that almost everybody here has their calculator today. Did I guess correctly? Have you got your calculator? Can you tell me what will be the effective annual interest rate if we compound this 4% per period 4 times in a year? 16.98. That's right. So 16.986%. Let me pause for a moment and make sure that everybody else agrees. I see some nodding heads. Okay. So nominally, someone could say, well, that's 16% per year, but not really. Really what it is 16.986% per year, and the reason why that's the real interest rate that you're experiencing is because you're going to pay interest on top of interest. Because of that effect that they're looking in the first quarter at how much your loan balance is, and they're wanting interest on not only the principal you took, but also on any interest that you haven't yet paid them. So that's the difference between nominal and effective. So in a lot of the problems you're going to work, the homework problems, you need to carefully pay attention to how often the interest is compounded. So I might, just to give you the practice of reading carefully, I may say, it's 8% interest per year, compounded semi-annually. So that would mean twice per year, and so then the interest rate per period would be 4%. So always pay special attention, not just to the interest rate, but also the compounding frequency. All right, now in today's in-class exercise, I hope you've printed it out. I gave you fair warning that I wasn't going to bring any of those handouts today, and I didn't. If you didn't print it out, maybe you can scoot next to somebody who did have it printed, or I'll bring it up on the screen and you can copy it down on a piece of paper. But really, I'm hoping that you've got the notes printed and the in-class exercises, and I think it's a great idea to put it in that 3-ring binder I've been harping about. We're going to use this formula a couple of different ways in today's in-class exercise. Let me bring it up on the screen. I think I've got it handy. We're doing number 5, compounding. Okay, here's what I'm going to suggest is let's work on the front 3 problems. I'll pause for a second, and what I hope happens when I stop talking is that you collaborate and chat amongst yourselves. I'll be circulating around with the answers just in case you have an individual question or you want to make sure that you've got the right thing. But we're going to find f given p, or you can use the same formula and just remember that it's a ratio. This formula of 1 plus I to the n power is ultimately the ratio of f to p. So you can use that same equation if p is the unknown rather than f. So let's solve problems 1 through 3. We'll go over the answer together and then continue on to the other problems that are on the back of the page.
So like when it says I%, does that mean you just put 6.5% instead of 0.065?
6.5% I, you'd need to have 0.065. So
Well,
I is expressed as a decimal.
Well, on the formula on the thing, it says like I%, and then it says like, the normal I. I guess I was curious, like if it has the percent there, does that mean that you would put 6.5?
Well, this is just because it's a way for us to summarize what kind of a problem it is. So what this really is f to p is 1 plus I to the n. Now the rest of it, like where I'm saying f to p, I%,
Yeah.
n, what I would say is this is a problem where you find f given p, I is 6.5%, n is 30. So that's just kind of a way of summarizing the parameters of the problem.
I see what you mean.
Okay, so I already showed you the solution to problem 1, where we're just finding the future amount. And in problem 2, you're using the same formula. It's a ratio. The ratio of the future amount to the present amount is 1 plus I to the n. So here in problem 2, the unknown is p, rather than F. So you can see what I've done is I've just algebraically rearranged this. To find P, I moved P over to the right-hand side of the equation and divided by 1.04 to the n power. So it's 95,000, which is the future value, divided by this factor. And this factor tells us the relationship between P and F. So if you want to have 95,000 in 15 years, when it's compounding each year, you should deposit 52,000 in the present. And that kind of illustrates the power of compound interest, right? Where you can withdraw $95,000 if you make a deposit of 52,000. Okay, so that's the first two problems. Oh, that's too small. And now here's the third one. In the third one, where we're comparing two different savings account options, there's Plan 1, which is straightforward enough because it's annual interest and compounded annually. So it's just 1 plus I to the n, where n is 10 years. That 125,000 turns into 257,000. Now, Plan 2, if you want, you could calculate the effective annual interest. I think it's maybe simpler if you just say that the number of periods is 120 months. So n is 120 months because we are compounding monthly. And so I also need to find the interest rate per period. So I know the annual interest rate, but since there are 12 periods in a year, this I that I'm going to put into the formula should be the interest rate per period. So it's pretty close, but 257,529 isn't as much as if we were doing this option 1. And so Plan 1 is better by about $99.92 over the course of the 10-year period. Okay, so this is just one to introduce you to doing calculations where it's not an annual compounding. It's compounding more than once per year. So the key here is just to change the n value and adjust the I. Okay, so moving on now to problem 4, you are going to calculate the effective annual interest rate for a nominal rate of 24%. So if it's quarterly compounding, then that means M is 4. If it's monthly compounding, that means M is 12. And if it's daily compounding, that means M is 365. So what you'll see is the interest rate, the effective annual interest rate, is different depending on how often you compound. So let's work on problem 4, and then on problem 5 is just additional practice translating a statement into a cash flow diagram. Let me bring the answers up on screen. We've only got 2 minutes left, and I want to make sure that the solutions are recorded in the video in case you want to go back through that again. Okay, so quarterly, monthly, and daily compounding, you can see that the effective interest rate would be 26.25, 26.82, or 27.11%. So the more often the compounding is, the higher the effective interest rate is going to be. Although the gap gets smaller and smaller as the compounding frequency increases. Okay, so remember, when you're calculating the effective interest rate, then just how often it's compounding is what you divide by and use as the exponent. Just more practice translating situations to a cash flow diagram. It says your uncle's going to purchase the truck, but it doesn't say how much your uncle spends, and so that's an unknown. It's just there's some outflow at time 0, amount unknown, and then it's going to generate revenue of $247,000 each year for 5 years. So 1, 2, 3, 4, 5 years of revenue. Selling the truck at the end of the period for $95,000, and then there is annual expenses and a one-time overhaul of $55,000 at year 3. So this is practice summarizing a problem statement visually. And well, you had a problem 6 as well, right? We'll spend a moment going over problem 6 at the beginning of class on Friday. So I'll see you then. Have a good day, everybody.
Can I ask you a